Hello ladies and gentlemen, welcome to my channel Simplified Radiology, where we try our best to conceptualize some topics so we can free the cramming part of our brain for other important stuff. Anyways, the topic for today is epidural versus subdural hematoma. Pretty basic knowledge, I know, but I'm one those people who forget the day-to-day stuff in crunch moments. Biconvex or elliptical? Which was which? Let's learn why do these present in the way they do, and for that we will need to go into the anatomy of it. Don't worry, not the detailed boring kind of anatomy, but just the absolute relevant and simplified version of it. Let's start. So the meninges consist of three layers. The innermost is the pia mater that is closely applied to the surface of the brain, above it is the arachnoid mater, and the outermost is dura mater. For this topic we are just concerned with the dura mater, so the dura consists of two layers actually. The inner one is called the meningeal or visceral layer, which follows the contour of the brain, and the outer one is called the periosteal or parietal layer because it is adherent to the periosteum of the overlying skull bones. The potential space between the periosteal layer and the skull is called the epidural space, and the potential space between meningeal layer and the arachnoid mater is called the subdural space. The thing to know about the periosteal layer is that each cranial bone has its own periosteal layer, so at the point of sutures the periosteal layer is really strongly adherent to its own bone, which means the epidural space across a suture is not continuous because there is no communication between the two spaces. The next point of note is that the meningeal dura, not being adherent to its bone, is continuous across the suture. But it doesn't stop at that, it has its own thing. Which is, that the meningeal layer has reflections called fulx and tentorium into the interhemispheric fissure and above cerebellum respectively. So done with the anatomy, let's put this knowledge to use. It can be safely said that the epidural space is a collective sum of smaller epidural spaces, and that although the subdural space is also partially compartmentalized by its reflections, it is still of relatively larger volumes than individual epidural spaces. Now think of one epidural compartment as a small balloon and the subdural space as a larger balloon. Now if I was to fill a small balloon with some water, the water would fill the balloon and the balloon will start to expand, but the water in the balloon will have to occupy the whole of its deflated volume before it starts exerting pressure on its walls, causing it to inflate. The big balloon on the other hand has a larger deflated volume, and thus will require greater amount of water to first fill the available space before causing it to inflate. So a small amount of epidural hematoma will cause the space to expand. On one side of it is hard, ungiving curved surface of the bone, so the only way for it to expand is towards the relatively softer side of brain, and thus assuming a biconvex or lenticular shape. Whereas for subdural space to acquire a similar shape it needs significantly larger volumes of blood for it to expand, which virtually rarely happens. So subdural hematomas with blood flowing freely over the surface of the hemisphere and only limited by its own reflections, acquires a curvilinear or elliptical shape instead. The subdural hematomas cannot cross the midline to spread over the other hemisphere though, because for it do so it would have to flow all the way deep into the interhemispheric fissure and make a U-turn back up to reach the surface of the other side, which again virtually never happens. To summarize, epidural hematomas cannot cross sutures and are biconvex in shape, and subdural hematomas cannot cross midline and are elliptical in shape. So now we know why each of these behaves the way they do, and you would have an easier time remembering this knowledge. I hope this video was informative and of help to you guys. If this helped you, please like and subscribe. Have a great day. Until next time, bye.